All right, welcome everybody. We're excited for this webinar. We'll be showing how common IDPs can be hacked with just $130 a month, which is how much Evilginx Pro costs nowadays, with some demos. We're going to start with a round of introductions and then get right into it. So hello everyone, I'm Kasha. I'm a product marketing manager here at Beyond Identity. And Nelson, would love for you to introduce yourself as well.
Hey everyone, I'm Nelson. I'm one of the co-founders here at Beyond Identity, and I run our solutions team.
Awesome, awesome. So before we get started, wanted to preface that we're not here to teach anyone how to phish. Our goal with this session is to educate the market on tools that are available today that can and are used as threats, and really to demonstrate them at a high level against common environments. So that way we can all be better equipped in the cybersecurity industry to protect against them. Anything else you want to add there, Nelson?
You got it.
Awesome. All right. So first, let's just understand a little bit about Evilginx. Um, Evilginx is a man-in-the-middle phishing kit used to bypass MFA, and really the ultimate goal is to steal session cookies. It was actually first created from a research project back in 2017 to demonstrate the weaknesses of current MFA and access systems, but of course, no good deed goes unpunished, and now attackers have modified it for malicious reasons. There are some key characteristics within Evilginx that wanted to highlight before we actually see it in a demo. It can clone login pages pretty much identically. It looks so believable that you would have to really just like look at the URL to identify that it's different from the actual login screens, which a lot of end users don't do. They believe the UI that they see in front of them. It intercepts usernames, passwords, but again, the ultimate goal is to steal the session cookies and can bypass MFA entirely. And now in terms of its impact, Evilginx and similar tools like other phishing kits have already been linked to surges in cookie-based phishing attacks targeting Entra, Okta, Google Workspace. We've seen in the most recent CrowdStrike threat report that 79% of detections in 2024 were malware-free, suggesting that attackers are prioritizing the path of least resistance that bypass traditional endpoint defenses entirely in order to reach their goals. So, what everyone's been waiting for, let's see it in action, Nelson. You ready?
All right, let's check it out. So what I have up on the screen here is my temporary instance I created. It has the repository that I cloned from GitHub. This stuff is not hard to find necessarily, where I think someone who is not adept at configuring this stuff may find it more difficult is actually creating the configuration and something called a fishlet. We've done all that. I'm not going to show how to do that part. What I'm very interested in showing is how, if you do have this configured and you know how to run a fishlet, without a lot of work and spending a lot of resources, you can actually phish most, existing instances of very well-used commercial SSOs. I'm going to show first how to do that against Okta. You see I have a fishlet already configured here. What I'll do is in Evilginx kind of speak the URL that you generate to send to a user is called a lure. So you'll see I will create one of those lures and get the URL for it. If I click on that lure and paste it on a browser, and this is where the adversary could get pretty imaginative, actually getting the user to click on something. It doesn't always have to be email. If you think you have email security, you're covered, phishing doesn't work. That's not always the case. There are many variations of how to deliver these lures to users. And of course, there's automation that can be used to figure out how to distribute it and how to make users click on it. And now we have our handy lure here, which I can just click on and deliver to a user. And notice how immediately, as soon as someone navigates to that page, we're actually going through the proxy I set up through Evilginx, and the proxy sees all the traffic that the user's sending to it, including, you'll see that as soon as I type a username here, that will actually show up in the proxy. Very easy. In this case, I've configured this Okta instance to not use a password is just using the push notification. If I had a password in place, that would also show up here. But I'm going to send myself a push, which I can see on my view in the window here. That push notification is the standard that Okta usually sends. Remember, we're still talking to Okta through the proxy. We're just trying to see all the traffic that's going back and forth. So I'm going to say yes, and that's going to complete the authentication proxy. But notice what happens now. Now I have all the authorization tokens, which is really what the adversary is after. I'm going to go look at my sessions, and I've done this a few times, so I have a few of them. I can pick up sessions 94 and then just copy this path here. I will be expiring the session as soon as we're done here, so no need to try to capture that. And now if I go to the real website, this is the actual Okta instance. You'll see that I've installed this little extension here called Storage Ace, where I can edit all the session cookies, paste my capture session, and refresh the page. And now I'm logged in as an adversary on my own browser with the user's session. And
Wow.
that's how the Okta fish works. Back to you, Kasha.
Yeah. Could we talk a little bit about, how this might be similar or different to Evilginx attacking an Entra instance?
Yeah, so very similar. I'm not going to show that here today. It's a little bit more complicated because there's additional controls that Microsoft has in place, but very achievable. What you typically use is a technique called man in the browser, which is similar to man in the middle. It has other ways of actually deploying it, but there's very similarly this fishlets that the community knows how to use. And if you do them, you will still be capturing a session. You can replay that session on a new browser in incognito, and you will be logged in as the user into an Entra account.
Got it. Very good to know. So let's see now, like what we were able to see um, on Nelson's screen, and then see how we can actually protect ourselves in the cyberspace. So, what phishing kits can bypass include usernames, passwords, SMS codes, and OTPs, push notifications like Nelson was showing, magic links. These are all things that a lot of environments use today, but can be bypassed. But there are things that continue to remain secure, and that remains to be biometrics, device-bound passkeys, device-native risk signals. These are things that are can't be replicated or stolen by attackers, and therefore those environments remain secure. And we actually have a demo of what Evilginx looks like against Beyond Identity that incorporates all of these characteristics into MFA to show you what it looks like.
So very similar setup. I can generate a lure, and it's still using the Okta fishlet. So same configuration as before. You'll see that I can type and generate the exact same URL. I'm going to copy that URL and paste it on my browser. But now, rather than logging in with just the plain Okta Verify Authenticator, which it suffers from this type of man-in-the-middle attacks, I'm actually going to use a separate account that's actually set up with Beyond Identity as an authenticator. You'll see when I type my account, the authenticator is running here on my user's machine. I can ask the user to provide a biometric optionally, but here's the critical element. We authenticated with Beyond Identity, but no session was captured. And the reason for that is because the authenticator is local on the device. We know what the URL of the IdP is. We perform the authentication request, but rather than sending the request back through the proxy, we send it directly to the real IdP, which in this case is Okta.
Awesome. Very cool. So now that we're wrapping up with these demos, I think I saw a couple of questions from the audience. And so If anyone has any questions, feel free to post them. We can answer them now or after this session just by emailing you. So Nelson, first up, we saw it on desktop browsers. What about Evilginx against mobile browsers?
So very similar setup. In some ways, mobile browsers are a little bit more effective because you're not always actually looking at the URL. They're kind of in an unexpected place in some mobile browsers. So the user doesn't have as much visibility into which URL they're actually putting their credentials in. That could be a phishing lure. Um, the process of delivering the lure is very similar as well. In mobile browsers, you can actually text the user the lure. Um, they can click it and it goes into the mobile flow, or you can have a QR code maybe planted somewhere in their environment with some messaging that wants have them want to scan that QR code and open the link. And then if you go through the authentication process, you still capture the session and you can replay the session anywhere. It doesn't have to be on a mobile browser.
Got it. Awesome. And how would someone even know if Evilginx was used against them? Are there any signs to detect it after the fact?
Yeah. So phishing of all flavors, the stratagem someone's using is trying to get you to go to the wrong URL. And in many of those cases, that URL does have valid certificates, so you're not going to see necessarily something wrong with that little lock that shows up on some browsers. The tricky thing about this and the hard thing to do is if the domain looks very similar to the real domain of the SSO, it's very hard for a user to spot it. If a user is paying attention and they do see that you're using a different character or maybe a completely different domain, but they think it's the domain that's associated with their single sign-on system, they can spot it and not go through with the login flow. But even in best case scenarios, we've seen the stats from KnowBe4. About 4% of users, even after going through training, will still click on a phishing link, will still go through with the authentication request. And you can do the math. It doesn't take long after that 4% actually adds up if you try many times.
You mentioned earlier in this session that email security tools, don't detect everything as well. Can you talk a little bit about, the efficacy of email security tools against phishing kits like this?
Yeah, I mean, best case scenario is the email security tool catches a link that looks suspicious. That process is always, by definition, going to be probabilistic because there's unlimited domains and adversaries can register any combination of letters. There are threat signals that email security tools are looking for to try to get ahead of the game, but they're not always going to be 100% ahead. So either you block every single link that comes through email and then users complain and it creates a problem. Or maybe you try to solve the problem lower down the stack where the thing that the adversary is after, the session cookie, the credential, that is harder to get for them. And that's precisely what we're trying to do with these demos.
Got it. Yep. And that's why Beyond Identity, with the technology itself, is engineered to be phishing resistant and block these attacks without using detection. And lastly, isn't FIDO phishing resistant? Why not use that instead?
Yeah. So we love FIDO. We're members of the FIDO Alliance. We think it's innovative technology. It's a great protocol. What we find a little bit limiting in terms of how FIDO is implemented typically in enterprise settings is the fact that, well, number one, the actual provenance of the keys, meaning where the keys are stored, can be different depending on the operating system. You can try to enforce hardware devices like YubiKeys for storing the keys. It's a whole set of problems with that approach. So what we try to promote is a best-in-class authenticator that not only holds the credential and stores those credentials securely, hopefully in hardware all the time, but also that can be a little bit smarter about the posture of the device as the user is trying to go through. Do you always want them logging into that critical application from a device that doesn't have your security controls in place? And can you actually establish the state of those security controls before any credential is used? And that's part of what Beyond Identity brings to the table.
Awesome. Yes. Well, that's all the time that we have today for questions, but anything that we did not answer, we'll be happy to follow up after this session. But thank you so much for your time, Nelson. Thank you for everyone, watching. If anything was interesting to you and you wanted to see more, get a one-on-one demo with Beyond Identity. Go to beyondidentity.com/demo. Thank you again. Bye.